All right, my friends, let's look at part A here. So the direction said show the algebraic analysis for finding the location of the tip of each petal for each rose curve, then graph it. So part of the points that you see here are for the algebraic analysis part, and then you'll see that part is for actually getting the graph done. So for part A, I'm hoping that going in, you saw this even number here, and so you knew that you were expecting double this number of petals, so you were expecting 8 petals. And then I'm hoping that you knew how to set it up to find the tip of each petal algebraically. So in this case, the reason you'll get twice as many petals as this number that you see here is because you get different petals resulting from positive and negative R values. So, you know the maximum value you're going to get out here would be 3, and so you just set R equal to either positive 3 or negative 3. Okay. Next, dividing both sides by 3, you get plus or minus 1 equals sine of 4 theta. This is unit circle ready. So if you think about a unit circle, you're looking for when sine would either be positive 1 or negative 1. So you set your angle, which is called 4 theta, equal to pi over 2, and then you just add multiples of pi to get future solutions. And then dividing both sides by 4 would give you theta equals pi over 8, it looks like, plus pi over 4n for all n from the set of the integers. All right, we'll come back and show the points in a little bit. So now let's talk about how to place things. So you could use this formula to generate your angles where you should go, have tips of your petals. So if you let n be 0, you'd have theta equaling pi over 8. So to figure that out, pi over 4, it takes 1, 2, 3 spokes to get to pi over 4. So it would take 1.5 spokes to get to pi over 8, since pi over 8 is half of pi over 4. So I'm going to go toward that 3. So 1, 2, 3. There we go. Let's see. Next, you could plug in, there are a couple ways you could do this. You could plug in 1 and then, add these together. You get 3 pi over 8, which means you'd have to go three of these distances. So 3 times 1.5 is 4.5. So 1, 2, 3, 4.5. Like you could do that. Another way to do it would be to figure you just keep adding multiples of pi over 4. And pi over 4, you could see, is a total of 3 spokes. So from here, 1, 2, 3. That's the way I like to do it. And then 1, 2, 3 again. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. There we go. And then fill it in. When you fill it in, you don't want them to overlap with each other. There we go. Okay, so let's talk about scoring. You gotta admit, that turned out pretty cute, right? Anyway, so hopefully that went well for you, and if it didn't, then let's talk about some partial credit. So you're gonna get 2 points for setting the equation up correctly. That means the plus or minus 3 over here. Now, if you jumped to the next step where you'd already divided the 3 out, this next step would also suffice for setting the problem up correctly, but 2 points for that. Next, we're going to give you 2 points for getting to the point where you had 4 theta equal to pi over 2 plus pi n. Oh, sorry, not 2 points, 1 point. I apologize. 1 point for that. And then, let's see, for this final equation here for theta, theta equaling, having this kind of initial condition here for pi over 8 is worth 1 point, and then showing kind of like, in a way, like the repetition of the function here, having that part of the equation, the plus pi over 4n is worth 1 point. So I don't think I'm going to have enough points to go around to give this part points. I do hope that you're starting to form a habit of having it. It's really going to be important as you move forward to be able to think through little details like this. So at some point, the devil really is in the details. So let's see. As far as the graph goes, you're going to get 1 point for having a rose curve with 8 petals of length 3 each. So even if you have them in the wrong place, if you have this, then you get a point for that. Okay. The other points are going to be for the tips of the petals being in the exact right place. So each point of accuracy that you see here is worth half a point. There we go. And so that would be 8, 4 more points there, and it adds up to 10 now. There we go. Okay, now for problem part B here, it was worth 9 points. This one we're expecting 3 petals, so you would get, you will only get tips of petals from, you'll get the same tips of petals, whether you put a positive 4 in or a negative 4 in. That's how it's different than the even ones. So there were 2 ways to set this up. One way, which is my preference, would be to set r equal to 4. And then the other way would be to set r equal to negative 4. One or the other, not both. Okay? Now, whatever you set r equal to, when you're done and you solve for theta, you have to realize that you have to pay attention to what you asked for. So for me, if I set r equal to 4, when I'm done, I would go to those angles that I'm going to get for my solutions, and I would go toward them 4, because that's what I asked for. Tell me when r is positive 4. Now, if you set r equal to negative 4, you would need, when you get your angles, you would need to go away from them 4, because that's what you asked for. So you and I would get different solutions for theta if I did 4 and you did negative 4. But as long as you interpret your answers the right way, we'll both get the exact same graph. Okay? All right, so that makes sense. So I'm going to go ahead and put 4 in, because I feel like it's less complicated that way. And then I'm going to divide the negative 4 over. And then this is unit circle ready, so I'm looking for when cosine would be negative 1. So I would find out that the angle, which is called 3 theta, would be anything that lands me here. So that would be pi from your initial condition, but then you could add any multiple of 2 pi to get back there. So that's what the 2 pi n is for. And then divide both sides by 3. And then that would be for all n from the set of the integers. Okay, now for graphing it, if you use this, you could just set n equal to 0. It would tell you theta is pi over 3. So for me, remember, I set r equal to positive 4. So pi over 3, when I'm facing pi over 3, I would go toward it 4, because that's what I asked for. And then I would need to, I could put n equal to 1 in, and then I'd get pi over 3 plus 2 pi over 3, which would be 3 pi over 3, or pi. So 1, 2, 3, 4 toward that. And then I could put 2 in, and I'd end up with 5 pi over 3. And go toward that 4. So anyway, the graph would end up looking like, there we go, something like that. Okay, scoring for this one, 2 points for setting it up. For this 2 points, you could either have positive 4 like I do, or negative 4. You should not have plus or minus 4. If you have plus or minus 4, you will not get these 2 points. Okay, next, 1 point for getting to the part that says 3 theta equaling pi plus 2 pi n. All right, from there, 1 point for getting your initial condition for theta of pi over 3, and then 1 point for showing that if you just add multiples of 2 pi over 3, you could get more solutions. All right, for the graph, you're going to get 1 point for having a rose curve with 3 petals of length 4. And then the last 3 points of accuracy are last 3 points are for 1 point per point of accuracy this time. So having it right there at, pi over 3, 4, and pi 4, and 5 pi over 3, 4. So there you go. Actually, I've been saying those backwards. So 4 pi over 3, 4 pi, and 4 5 pi over